The first method to determine the reaction mechanism is to isolate the intermediate. Here, if you are able to isolate the intermediate, and we can characterize it by spectroscopic methods or analytical methods. If that intermediate is characterized, we can come to know that the mechanism what is occurred is through that intermediate formation. But however, this has a daunting task because of the fact that the intermediates which are formed are generally highly unstable as they are highly reactive. But in some cases, we will be able to isolate the intermediate. How can we isolate the intermediate? We can stop the reaction in between after a short time of reaction and we can isolate. Before the product is formed, intermediate is formed. Before product is formed, if we are stopping the reaction, the intermediate which is formed, we can isolate. Or we can isolate the intermediate by carrying out the reactions under milder conditions. In example, Hoffman's bromamide reaction, we know that amide, when it is treated with potassium hypobromide, it gives rise to an amine which is having one carbon less than the amide, along with the formation of potassium bromide, potassium carbonate, and water. In this reaction, the reaction was carefully controlled and it by carrying out under mild conditions, and the intermediates like N-bromoamide, the nitrene, and the isocyanate, all these were isolated and it is were characterized. Based on the structure of these intermediates formed, the mechanism has been put forward. This is the easiest way to determine the mechanism of the reaction. However, it is a challenging task because of the fact that the intermediates formed are highly unstable, like nitrines are highly unstable. Thus, in all the cases, it may not be possible. If it is not possible, what should we do? For every problem, there is a solution. If at all we are not able to isolate, during the course of the reaction, we can detect the formation of that intermediate either by IR spectroscopy or NMR spectroscopy or any other spectroscopic methods. For example, in nitration of benzene, the following mechanism has been put forward. Nitric acid reacts with sulfuric acid to give rise to nitronium ion. During the course of the reaction, the nitronium ion is an intermediate formed in the reaction, and this nitronium ion reacts with the benzene, and the nitronium ion replaces the H plus ion in the benzene ring and gives rise to nitrobenzene. Nitronium ion is highly unstable and it is unisolable. Thus, it was detected by NMR spectroscopy or IR spectroscopy. In this case, it has been determined by Raman spectra. The nitronium ion peak in the Raman spectra indicated that nitronium is the intermediate form. This detection of nitronium ion as an intermediate, it gives an evidence that the mechanism proposed is right. This is another method of knowing the reaction mechanism. Which is this reaction? An alkyl halide I have taken and treated with a nucleophile like cyanide ion. The attack has taken from the backside. A bond is formed slowly between the carbon and the nucleophile. During the formation of the bond, the carbon and halogen bond has been slightly broken and complete breakage of bromine occurs, and bromine along with its electron pair it leaves, and cyanide ion along with its electron pair attacks on the carbon. I have started with starting material with S configuration and ended up with compound or the product with R configuration. Here, the stereochemistry of the molecule has changed. I've started with S and ended up with R. This stereochemical inversion can be taken as an evidence. Stereochemical evidence in case of SN2 mechanism, there is complete inversion of the product. Inversion of the product, I start with S, I end with R. And vice versa is equally true. I start with R, I end with S. It indicates that the attack has taken place from the backside and the bond breakage and bond formation has occurred simultaneously, and that's why the inversion has occurred. This is how we determine the mechanism of the reaction. Here, intermediates is neither isolated or it is formed at all. If it is formed only, we can isolate. It is not formed. There is a transition state where half bond is formed and half bond is broken. In this case, when intermediate is not at all formed, a transition state is formed. Transition state is an intermediate state. In this case, stereochemical evidences can be taken to determine the mechanism of the reaction. By identifying the types of products formed, we can also write the mechanism for the reaction. Which type of product is formed? When I take 2-bromobutene and treat with alcoholic potassium hydroxide, I get 2-butene and 1-butene, and 2-butene is the major product which is formed in 80% concentration. Another is 1-butene is the minor product. Based on the amount of product formed, we can determine the mechanism of the reaction and we can propose the mechanism. If it abstract the proton from there are two carbons adjacent to the carbon which is having halogen. It is basically an elimination reaction where hydrogen from the beta carbon and halogen from the alpha carbon got eliminated to give an alkene. There are two beta hydrogens from on the right hand side and on the left hand side. If the proton is abstracted from the carbon on the right hand side, I get 2-butene. If it abstracted at the alpha carbon, then I get 1-butene. Based on the product formed, we can propose the mechanism how the reaction might have occurred. This is another method to determine the mechanism of the reaction. We also use isotopic effect. What is this isotopic effect? We replace the bonded atoms by the heavier isotope. When I replace it by higher isotope, what happens? As it is heavier, the bond breakage will be slower. If the rate of reaction is slowed down, then bond breakage at that step has occurred. Comparison of the rate of reactions in the virginal bond breaking and in the heavier isotope substituted bond, we can propose the mechanism. If I take the alkyl halide like here and treat with the base, it abstract a proton and bond is formed between carbon and halogen is eliminated. An intermediate is formed like where the half bond is formed between hydrogen and ethanol, half bond is broken between carbon and hydrogen, and slightly bond is formed between carbon and carbon and halogen bond is broken. All occur simultaneously in a single concerted step to give rise to an alkene and ethanol and bromine. Here, if I replace by deuterium, it's a heavier isotope. The first step, what is proposed is the proton abstraction takes place. If that is the rate determining step, Then, if at all I replace it by deuterium, abstraction of deuterium takes more time. Suppose this first reaction takes place in 1 hour, it takes place in 2 hours, as it is a heavier isotope. Means what it indicates, the proton abstraction is the requirement for the reaction to occur. This is how we can propose the mechanism for the reaction. Isotopic replacement is one method. Another method is isotopic labeling, which is called as tracer technique. Here, if I take RCO minus and treat with cyanogen bromide, I get RCN. I will take RCOO, in which carbon 12 is replaced by carbon 14. It's heavier isotope. And in product, I get RCN, and C, this is having a radioisotope. What it indicates? The substitution of CO2 by Cn is not there. Cyano group in product is not coming from this cyanogen bromide. It has come from other the same starting material. Means it is not simple substitution. We use C14 labeled carboxylic acid and it gives nitrile with C14 labeled carbon. Then simple substitution of carbon dioxide by cyanide is ruled out. There is another mechanism that we can say. This is how we determine the mechanism of the reaction.